Welcome to this video on equations of tangents. So what we've been looking at so far is if we've got a function, say f of x, and we find its derivative f dash x. What f dash x is an equation or a function that describes the gradient or its rate of change of the function at any given point, the function f of x. So what we're now going to do is, what if I wanted to know the equation of a tangent line at any given point of a function, say f of x? So what we've got here, we've got this y is equal to f of x at x equals a. So at some arbitrary point a, the gradient we know of the function f of x, or in this case f of a, is just going to be f dash a. That's our derivative. A is a value of x, which we'll substitute in a bit later. What we need to do is find, for a point, let's go a dash f of a. So we're f of x, where this is basically our y coordinate and our x coordinate. Yeah. So we've got our f dash a, which is our gradient formula, is equal to y minus f of a, a point of the function at a, divided by x minus a. So x is going to stay there. This formula looks suspiciously like the one you've probably noticed up here, which is our formula for our gradient. The slope of a line is equal to y2 take y1 over x2 take x1. It's worth noting that a tangent line to a function is going to be a straight line. So it's going to have the form of y equals mx plus c. So when we rearrange this, we actually get y being equal to f dash a, which is our slope, in this case m, minus x minus a plus f at this point a. So let's do it with an example and see how it looks. So you might want to try graphing this in calculator to see what it looks like as well. Alright, so first things first, we need to work out the derivative of this. We're getting really competent at working out derivatives by now, I hope, so let's go through, let's punch it out and calculate it. So we're going to have to use our chain rule, because we've got a function within a function. So f dash x, let's work out our u and v. So u is equal to x squared plus 5, or u dash is just going to be x squared plus 5. Now this is all to the power of a half, so it's going to be minus a half with half out the front, which equals 1 over the square root of x squared plus 5. V, if we go inside, been equal to x squared plus 5. This v dash, sorry, is just equal to 2x. Alright, so our chain rule is going to make this look something like a half x squared plus 5 all to the power of minus a half multiplied by our derivative inside, 2x. So what does this look like when we rearrange it or make it simpler? Because we could go through and start plugging in values now. Why not neaten it up? F dash is going to be equal to 2x divided by 2 times the square root of x squared plus 5. Your 2's will cancel each other out, and you'll end up with an equation that looks x divided by x squared plus 5. Alright, now let's substitute some values in and see what we get. So, the first one we're going to do, let's look at plugging in and working out what is the gradient at a point where x is equal to 2. So what we need to do is find out what the gradient is at that point where x equals 2. So for that, we plug 2 into here and see what we get. So I'll do it out here. F dash 2 is equal to 2 divided by the square root of 2 squared plus 5. So 2 squared plus 5. So I'm going to work along this way so we leave a bit of space down the bottom. So 2 divided by 2 squared is 4. 4 plus 5 is just 9. So the square root of 9, which we know is just 3. So our answer, or our gradient at the point where x equals 2 is going to be 2/3. So what we can do here is substitute that into our equation, or into our basic form here, where it's this bit here. We know that a is equal to 2, and at that point, y also must equal 3. If you're not sure, let's plug in to this equation 2. So 2 squared, which is 4, plus 5 is 9. So the square root of 9 is just 3. So you're actually given f0 here. So let's plug the values in here and come up with our answer. So y is equal to 2/3 x, because x just stays as is, because we need an x term and a y term in our y equals mx plus c, minus a, in this case 2, plus 3. Let's simplify it a bit. Y is equal to 2/3 x. Let's move that x down a little bit. 2/3 x plus 5 on 3. Now the reason it's 5 on 3 is if we go 2/3 times 2, or minus 2, so 2/3 times minus 2 is just going to be minus 4 on 3. Remember, for multiplication, you just multiply the top, multiply the bottom. So 2 times minus 2 is minus 4, 3 times minus 1, 3 times 1 is just 3. Okay, then we've got to add it to 3. So minus 4 on 3 plus 3. Or in this case, it's 3 on 1. If we multiply this whole bit here by 3, again, we can use our cross multiplication. 4 times minus 4 times 1 is just minus 4. 3 times 3 is 9. And we can make this all over 3 times 1, which is just 3. So, minus 4 plus 9 over 3. I do apologise, that should be a bit straighter. It's just going to equal 5 on 3. And that's our answer. We can then now use this, well, we've found the equation of the tangent at a point where we've been given, which is 2 on 3. 2, x equals 2, y equals 3. We're given a formula and a point, and we've worked out the equation of the tangent line to it. Hopefully this makes sense. We can then go through and answer some questions. If you've got any questions, feel free to ask, or if you want clarification, feel free to ask. Hopefully this video makes sense, and as always, thanks for watching.